Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
How Dorothy Hodgkin revolutionized science and shattered gender barriers. She unlocked a molecule and changed the entire world. This molecule didn't just impact medicine, it transformed how we understand life itself. And all of this was achieved with just a microscope and a handful of crystals. Imagine this: a scientist sitting in front of a microscope, facing nearly invisible tiny crystals, yet able to solve a major health mystery that affects us all. Now, that's the real magic of science. The great scientists you know? There's always a hidden story behind them. Today, let's talk about Dorothy Hodgkin. Not only did she reveal the microscopic secrets of life, but she was also an explorer who never gave up. Her work directly led to breakthroughs in molecular biology and drug research. Without her efforts, we might still be struggling to understand molecular structures. She's like Sherlock Holmes in the world of chemistry, only, instead of solving crimes, she uncovered the mysteries in every cell of life. Hodgkin's name is almost synonymous with science today. In 1976, she won the Nobel Prize in Chemistry for decoding the structure of vitamin B12, becoming only the second woman in history to do so. This wasn't just a casual achievement, it was a monumental contribution. She didn't just look at the surface of molecular structures, she revealed the deep, hidden secrets within them. Vitamin B12 is crucial for our bodies, especially for maintaining our nervous system, but before Hodgkin, no one truly understood its complex structure. So, how did she do it? The tools she used might sound like something from a sci-fi movie, but in reality, her weapons were simple: just a microscope and some crystals. What she did was like piecing together a giant puzzle, using tiny molecular fragments to unlock one of the biggest secrets of life. And in doing so, she revealed a deeper truth: in the world of molecules, even the tiniest changes can lead to massive effects. Sometimes, a scientist's work seems ordinary on the surface, yet it subtly changes the entire world. Hodgkin's achievements were just like that. Her discoveries didn't just push science forward, they laid the groundwork for future drug research. Without her persistence and exploration, we might still be struggling to understand the molecular structure of medicines. But instead, she used a microscope and a handful of crystals to unveil the secrets of life itself. That's what made her extraordinary. As the saying goes, great things come from small beginnings. Dorothy Hodgkin's work wasn't just about making discoveries, it was about changing the way we see the world. Through patience and determination, she opened doors to new realms of science, leaving behind a legacy that continues to impact medicine and molecular biology to this day. Born in 1910 in Alexandria, Egypt, Dorothy Hodgkin's childhood was anything but ordinary. Egypt was still under British colonial rule at the time, and her father, John Hodgkin, was a British diplomat managing relations between Egypt and Britain. Her mother, Barbara, was a chemistry teacher, which meant Dorothy grew up in an environment rich with science and diplomacy. From an early age, Dorothy was surrounded by curiosity and knowledge, with her mother encouraging her interest in chemistry and often explaining the basics of the subject. This early exposure sparked a lifelong fascination with the microscopic world of molecules. You might wonder, how did a young girl, growing up in such an unusual setting, develop such a deep interest in chemistry? Well, Dorothy was always a bit different. Even though Egypt wasn't exactly a hub for scientific research, she discovered a powerful interest in nature's laws, thanks to her parents. She loved experimenting in the home lab and would often visit the local library to read up on complex chemical reactions and the microscopic world. Her childhood was filled with exploration, setting a solid foundation for her future scientific career. Her school life was far from typical too. In early 20th century Egypt, girls' education wasn't exactly a priority, but Dorothy's thirst for knowledge stood out. Especially when it came to chemistry, she displayed remarkable talent. By her teenage years, she was already learning advanced chemical concepts, even grasping complicated chemical equations and experimental principles. Not only did she excel in school, but she also applied what she learned at home, using her kitchen as a makeshift laboratory. Her teachers quickly recognized her potential and saw that this young girl's future was undoubtedly tied to science. By the time Dorothy was 16, her path was clear: she was going to become a scientist. To pursue this dream, she set her sights on further academic opportunities and decided to head to Britain. The scientific world of the 1910s was still very much male-dominated, and it wasn't easy for women to carve out a space. But this wasn't a problem for Dorothy. Her determination and talent were enough to help her navigate this male-dominated field. She eventually chose to study at Oxford University, a place full of challenges and opportunities. She became one of the first female chemistry students at St. Hilda's College. At that time, Oxford's chemistry department was almost entirely male, and female students were rare. It's easy to imagine the challenges she faced. Academic pressure aside, she was up against societal prejudices about women in science. Many believed that women weren't cut out for experiments or scientific research, and her male classmates often viewed female scientists as outsiders. But Dorothy didn't back down. Her brilliance and perseverance quickly earned her a reputation at Oxford. Through hard work, she started to break through gender barriers, showing that women could make significant contributions to science. Her professors and peers soon respected her for her exceptional skills. I remember one of her mentors joking, "If science were a boys' club, Dorothy would be the only one bringing chemicals to the club." In many ways, Dorothy's success was a seamless blend of woman and chemistry. Her achievements at Oxford not only paved the way for future female scientists but also forced the scientific community to reconsider an old belief that gender had anything to do with one's ability to be a great scientist. What truly mattered, Dorothy showed, was a passion for science and an unwavering determination to explore. Her university years weren't easy, but she always faced challenges with a lighthearted and humorous attitude. Although Oxford's chemistry department had once been a boys' club, Dorothy used her talent, determination, and sense of humor to carve out her own space. She showed that anyone could change the face of science, even in a world dominated by men. Dorothy Hodgkin's journey teaches us that with talent and perseverance, we can break down barriers even in the toughest environments. Dorothy Hodgkin's journey into science wasn't a walk in the park, it was filled with obstacles and breakthroughs. At Oxford University, she first encountered something completely unfamiliar: X-ray crystallography. This technique would lay the foundation for her later accomplishments. Now, X-ray crystallography might sound like something straight out of a sci-fi movie, but it's not as complicated as it seems. In simple terms, it uses X-rays to pass through crystals. By analyzing how the X-rays interact with the crystal, scientists can figure out the internal structure of that crystal. Think of it like using a magnifying glass to peer at something tiny under a microscope. If you can see the details, you can begin to piece together what the object is made of. For Dorothy, this was an exciting discovery. But how did she get interested in it? Funny enough, it wasn't because she had a burning passion for crystallography. She actually stumbled upon it when she overheard a mentor talking about its potential. She quickly realized that X-ray crystallography wasn't just for analyzing simple materials, it could unlock the mysteries of complex biological molecules. For a chemist like Dorothy, it felt like stepping into a whole new world, and she decided to dive right in. The real challenge with X-ray crystallography, though, lies in the quality of the crystal samples. The more complex the molecule, the harder it is to prepare a crystal. One of Dorothy's early goals was to decipher the structure of vitamin B12. This vital molecule was key to human health, but back in her day, no one had fully figured out its structure. It seemed like an impossible task, like trying to put together a puzzle without instructions. Every piece of the puzzle represented a tiny, invisible molecule, and getting each one in the right spot was crucial. Sometimes, scientific research feels a lot like a detective game, but instead of solving crimes, the scientist is solving molecular mysteries. Dorothy became an expert at this, analyzing every clue in the crystal, piece by piece, until she cracked the code. Her work wasn't without its challenges: choosing the right samples, interpreting the data, and navigating through uncertainties. The answers weren't always clear. But after a lot of trial and error, Dorothy finally unlocked the structure of vitamin B12. Vitamin B12 is no simple molecule. It has multiple ring structures and a unique cobalt atom at its center. Dorothy didn't just observe the structure, she discovered where the cobalt atom was located. This finding was groundbreaking, as the position of the cobalt atom is critical to how the vitamin works biologically. Her discovery gave scientists a deeper understanding of vitamin B12's role in our bodies, unlocking a key code of life. But Dorothy's work wasn't easy. At the time, X-ray crystallography was still in its infancy, and processing the data was a long, tedious, and complex process. The vitamin B12 molecule was enormous, and mapping its structure required far more time and technology than most scientists of the era could have imagined. Yet, with unwavering determination and brilliant insight, Dorothy overcame one technical hurdle after another, eventually revealing the secrets of vitamin B12. Her research didn't just complete a scientific task, it became a vital resource for future drug development and molecular biology research. Dorothy didn't stop at vitamin B12. She also studied the structures of other important biological molecules, with one of her most famous projects being collagen. Collagen is a key protein in human skin, bones, and connective tissues, and its molecular structure was a mystery at the time. Using X-ray crystallography, Dorothy cracked the code, making huge contributions to both medicine and biology. Her work didn't just push forward the field of biochemistry, it opened up new pathways for drug development. In science, sometimes it's not about the flashy discoveries, it's about the quiet breakthroughs that slowly change the world. Dorothy's research, filled with perseverance and meticulous analysis, laid the groundwork for so many advancements that followed. She showed the world that with patience and precision, even the smallest details can have a huge impact. In 1976, Dorothy Hodgkin reached the pinnacle of her career when she won the Nobel Prize in Chemistry, becoming only the second woman to ever receive the honor after Marie Curie. This award wasn't just a recognition of a lifetime of hard work, but also a tribute to her groundbreaking contributions to biochemistry. Hodgkin's work in X-ray crystallography, especially her detailed analysis of the structure of vitamin B12, changed the way we understand complex molecular structures in biology. Her Nobel-winning achievement was crystal clear. She deciphered the structure of vitamin B12, one of the most important molecules for human health. This was no small feat. It provided us with crucial insights into how this vitamin works in the body and laid the groundwork for future molecular biology research. Her findings didn't just break new ground in chemistry, they also had a profound impact on medicine, especially in areas like anemia treatment, making vitamin B12 a cornerstone in medical science. When Hodgkin received the Nobel Prize, the scientific community was buzzing with excitement. After all, a Nobel isn't just about recognizing a single individual's work, it's a reflection of an entire era's achievements. Her win marked a significant milestone for women in science, especially in a field that was predominantly male at the time. Her success became a symbol, showing that talent and hard work could break through any gender barrier. It opened new doors for women scientists around the world, inspiring countless others to pursue careers in research. So, how exactly did Hodgkin change the game in molecular biology and biochemistry? Her work wasn't just about cracking the code of a single molecule, it opened up an entirely new world of understanding when it came to the structures of life's molecules. Take vitamin B12, for example. Its structure is incredibly complex, featuring multiple ring-like structures and a unique cobalt atom. Through X-ray crystallography, Hodgkin uncovered these structures, creating the first accurate 3D model of vitamin B12. This discovery didn't just help us understand how vitamin B12 functions in the body, but it also became a valuable reference for drug development. More importantly, Hodgkin's work laid the foundation for advances in molecular biology and protein engineering. Her X-ray crystallography methods became a critical tool for studying large molecules, helping later scientists unravel complex biological phenomena. In the field of drug development, Hodgkin's research provided a new way of thinking, allowing scientists to design more targeted therapies based on molecular structures. Her discovery of vitamin B12's structure didn't just enhance our understanding of biology, it also guided the development of better treatments for various health conditions. Hodgkin's contributions went beyond academic breakthroughs, they had a deep impact on medicine, drug development, and molecular biology applications. Her research forced the entire scientific community to rethink the role of molecular structures in disease treatment, propelling biochemistry and molecular biology into new realms of progress. The ripple effects of her work can still be felt today, influencing countless studies and providing the groundwork for future discoveries. And let's face it, getting a Nobel isn't easy, especially when you're not cracking a political code but working with tiny molecules. Solving molecular structures is no walk in the park. Unlike international relations, molecules don't have a lot of gray areas. Every single detail in those structures can change the entire scientific landscape. Hodgkin's achievements weren't just personal triumphs, they were monumental contributions to the scientific community. Her efforts benefit us all. But her story didn't just shake up science, it shattered gender stereotypes. As a female scientist, Hodgkin's success carved a path for women everywhere in science. Through her determination and brilliance, she proved that gender doesn't define your place in the scientific world, passion and talent do. Her story continues to inspire women to pursue careers in science, showing that no matter your gender, if you have the passion and the talent, you can carve your own space in the world of discovery. As the saying goes, where there's a will, there's a way. Hodgkin's journey is the perfect testament to that. Her legacy is not only about her scientific discoveries but also about the doors she opened for future generations, proving that with perseverance and talent, you can change the world, one molecule at a time. Dorothy Hodgkin's story is a beautiful example of how love and science can come together to shape something truly extraordinary. She met her husband, Herbert Hodgkin, in the early 1930s at Oxford University, where they quickly became both academic partners and life partners. Herbert was a brilliant chemist and played a crucial role in Dorothy's career, even though he wasn't directly involved in her groundbreaking work on vitamin B12. Their partnership, however, was one built on constant support and collaboration, both in and out of the lab. In 1937, they got married and began their professional collaboration in earnest. Over the decades, despite Herbert not actively participating in her research, he was always by her side, offering his advice, helping with experimental designs, and providing intellectual support. His encouragement extended beyond just the scientific discussions. He was her rock in both their professional lives and personal lives. A fellow scientist himself, Herbert was always there to give Dorothy the freedom and emotional backing she needed, especially when she dove into the challenging world of X-ray crystallography and vitamin B12 research. Their partnership went beyond a marriage, it was a true collaboration. Even in the 1960s and 1970s, as Dorothy's research reached new heights, Herbert remained her unwavering supporter. In 1976, when Dorothy was awarded the Nobel Prize in Chemistry, Herbert felt immense pride, not just for his wife's achievement, but for the joint effort that had led to such an iconic moment in science. But it wasn't only Herbert who helped shape Dorothy's path. Her mother, Barbara Hodgkin, also played a vital role in Dorothy's early life. Barbara, a chemistry teacher, was the one who instilled in Dorothy an insatiable curiosity for science. Although Barbara passed away when Dorothy was still a teenager, her influence lived on, shaping Dorothy's journey as a scientist. Dorothy often reflected on how her mother's teachings, especially in observation, analysis, and perseverance, gave her the foundation to navigate the male-dominated world of science. Dorothy's success wasn't just about breaking through the scientific barriers, she also broke through the barriers women faced in academia. As a wife and mother, balancing family life with her scientific career was no small feat, but she managed it with remarkable grace. She and Herbert had 2 children, Peter and Lily, and while Dorothy's work was demanding, especially as her vitamin B12 research deepened, she always made time for her family. She wasn't just a mother, she was also Herbert's most trusted partner. Dorothy valued her family deeply. Between experiments, she'd spend quality time with her children, taking them on trips or organizing outdoor activities. Despite the long hours and solitary thinking required for her work, she found a way to balance the demands of science with the needs of her family. At home, she was a loving and dedicated mother, while in the lab, she was a focused and passionate scientist. Her ability to juggle these 2 worlds set a powerful example for future generations of female scientists. Through precise time management and careful planning, Dorothy made it work. She often said, "Time is the most valuable resource I have. I must make every minute count." Her family recognized her dedication not only in the lab but also in how she ensured that they felt loved and supported, even during her busiest days. Her disciplined approach to work and life made her a role model in both her scientific and personal spheres. It's almost funny to think of Dorothy's role at home being just as precise as it was in the lab. She didn't just figure out the complex structure of vitamin B12, she also figured out how to keep her family life running smoothly, ensuring every part of her world was in balance. Dorothy's approach to life shows us that a woman in science can excel in the lab and still be an essential, caring figure at home. She proved that it's entirely possible to achieve a perfect balance between career and family, and her example continues to inspire women in science today. As they say, the proof is in the pudding, and Dorothy's life was a testament to that. Her achievements in science and her ability to maintain a loving, balanced family life make her a role model for women everywhere. She cracked the code of molecular structures using X-rays, and with intelligence and determination, she shattered the gender barriers of the scientific world. You might have heard of Dorothy Hodgkin, but how exactly did she change the world? First, her groundbreaking research completely transformed our understanding of the molecular structure of vitamin B12. In 1976, she was awarded the Nobel Prize in Chemistry for this work, becoming only the second woman after Marie Curie to win the prize. But her contributions went far beyond that. Her work paved the way for advancements in modern drug development and protein engineering. She revealed the unique position of the cobalt atom in the vitamin B12 molecule, helping scientists understand the mechanisms behind many diseases and driving the development of new treatments. Imagine that her work didn't just influence treatments for anemia and metabolic diseases, it changed the way we understand how biological molecules interact. In the world of drug development, Hodgkin's X-ray crystallography techniques became the foundation for designing and creating new medications. Every time you get a new prescription, there could be a little bit of Hodgkin's research behind it. But all of these incredible accomplishments didn't come easy. Behind her success was a powerful determination to fight gender bias in a male-dominated scientific world. Back in her time, women were almost invisible in science, yet Dorothy Hodgkin broke through that barrier. She earned worldwide recognition through her talent and hard work. Her achievements proved the immense potential women have in science and opened doors for future generations of female scientists. Her success wasn't just a personal victory, it became a beacon for countless women to pursue careers in science. Hodgkin's story tells us all that gender isn't a barrier to success in research. She dismantled the old idea that women couldn't excel in science and made it clear that the world of science belongs to anyone who loves to explore, regardless of gender. Through her life and work, she showed us that women could reshape the landscape of science and even lead the way in future innovations. This is more than just a scientist's story, it's the story of a woman who, despite facing challenges, bravely chased her dreams. Dorothy Hodgkin's success became a symbol for female scientists worldwide, encouraging them to break through barriers and follow their own scientific dreams. You might be wondering, if you had the chance to unravel a molecule and discover the secrets of life, what would you choose? Hodgkin's story shows us that the journey of science is full of challenges, but also full of hope. Her legacy is not only scientific achievement, it's a model for anyone, especially women, daring to explore the unknown. Her life, much like her research, was filled with a fearless pursuit of the unknown. She proved that science has no limits, only the fearless questioning of what we don't yet understand. Her story will never grow old. It's a reminder that if you ask why, you'll find how.
Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.